Hey guys, this is 2.5 and 2.7 homework, or 2.5 through 2.7 homework. Okay, what is the value of the limit as h approaches 0 of that expression? Now, at this point, we know shortcuts. And so, this is the definition of a derivative, but we want to use its shortcuts because they're a lot easier. I can follow this through and just do the whole manipulation tactic and get the derivative that way. But instead, what I'm going to do is I'm going to analyze this expression right here and decide, one, what is the function of x that I'm using to take the derivative of, and at what value of x am I taking the derivative. So what would be the function here? So for me, I can see the first part, this right, if I think about the formula, the limit as h approaches 0 of f of x plus h minus f of x over h. Now, specifically though, we could call x a. That's the value that we're evaluating it at. So you can see here, we can already just see what value of x that we're taking the derivative at. It's at 16. And we're inputting that into this spot right here, which would be x, right? So I can see my function is going to be x to the fourth. And what we're trying to find is f prime of 16. What is that equal to? So let's find f prime of x, because that's what this is right here. This right here is saying f prime of 16 when f of x equals x to the fourth. That's exactly what this expression is saying right here. Okay, so now I don't have to follow through on this definition to find the derivative. Let's just use the shortcut. As long as I write this correctly, 1/4. So using our shortcut rules, I know that the derivative here is going to be 1/4 x to the negative 3/4. Because you drop the power, that becomes the constant outside here, and then you decrease this by 1. 1/4 minus 1 is negative 3/4. Another way of writing this would be 1/4 x to the positive 3/4. So in that case right here, f prime of 16 would be equal to 1/4 times by 16 to the 3/4. This right here is 16 to the 1/4, so the fourth root of 16, and the fourth root of 16 is 2, so 2 to the third, so that's going to be equal to 1/4 times by 8, that's going to be equal to 1/32. That is my derivative right there. And I guess I should have pointed out that another way we can verify that this is our function and this is the value of x that we're evaluating at. Notice here that this is 2. So what would f of a be equal to? So if I plug in 16 right here, the fourth root of 16 is 2, which is why we have that right there. Okay, very similar problem right here. What is this right here? So this is saying the derivative, but f prime of what? So notice here that this is x plus h, but this is the function right here. So this exactly is what we're taking the derivative of, but with the plus 4, you can see that. So x squared, so f of x, so f of x is going to be equal to x squared plus 4x. So you can see that that is in case that is our function right here. Now we're not taking the derivative of it at a certain value, but this just means what is the general derivative of it. So f prime of x is going to be equal to 2x plus 4. Just using the derivative shortcut rule. Drop the power, decrease it by 1. This case right here, the power is 1, drop the power, that's still going to be 4. X to the 0 power is going to be 1. So this right here is what this expression would be. And so it's going to be C. If g is the function defined above, if g is the function defined above, then g prime of 3 is. So g prime of 3, notice here that this is a piecewise function. And so, for the g prime of 3 to exist at this point, the slope from the left and the slope from the right have to be equivalent. But I can already see that the slope from the left of this graph right here is -1, and the slope from the right of this graph is +4. And so since they're not equivalent, it's going to be non-existent. I could also just see, no. It won't help. We're going to be continuous at this point, because if I plug in 3, I get 0 here. If I plug in 3, we're going to get 0. So yes, it's continuous, but the slopes are going to be different at that point. So, okay, for 4, let f and g be differentiable functions such that f prime of 0. Sorry, I'm adjusting my headset way too much. Let f of g be a differential function such that f prime of 0 equals 3, g prime of 0 equals 7. If h of x is equal to this right here, what is the value of h prime of 0? So let's find h prime of x. So h prime of x is going to be equal to, take the derivative, that's going to be 3f prime of x. The derivative of f is just going to be f prime, and then we have a constant 3, so we keep the constant there. Same thing here, we have a constant, -2, and the derivative of g is going to be g prime of x. And now here, we have a constant times by cosine of x. I just need the derivative of cosine, and the derivative of cosine is negative sign, and so that's going to make that +5. +5 sine of x, and then the derivative of a constant is 0. So there you go. So this is h prime of x. Now let's find h prime of 0. So that's going to be 3f prime of 0 minus 2 g prime of 0 plus 5 sine of 0. So it's going to be equal to 3. F prime of 0 is 3 minus 2 times by g prime of 0, and that's 7. And then plus 5, well, nope, not plus 5, because sine of 0 is 0, so that's just going to be 0. So this is going to be 9 minus 14. It's going to be equal to -5. Let f be the function given by here. What is the value of f prime of -2? Let's find f prime of x. So f prime of x, drop the 3 and multiply it with the constant that's already there. 15, decrease the power to x squared, minus 3, and then the derivative of constants only is 0. So this right here is our derivative. F prime of -2 is going to be 15 times by -2 squared minus 3. So this is going to be 15 times by 4 minus 3, and that's going to be equal to 60 minus 3, which is equal to 57. Graphs of the linear functions f and g are shown above. If h of x is equal to f of x plus g of x, then h prime of x is equal to, so h prime of x is equal to f prime of x plus g prime of x. Now what is f prime of x? So here is f, and because they're linear functions, f prime is constant, so the slope here is always going to be 1. For g, the slope here is over to, -2/3. So minus 2/3. So that's going to be equal to 1/3. For 7, looks like we're just using the definition again. So the limit as x approaches 0 of 5 to the x minus 1 over 0. So f of x, in this case, looks like it's going to be 5 to the x. And then at x equals 0 seems to be the case that we're taking the derivative, and that checks out because, so f of x minus f of a pretty much. So in that case right here, 5 to the 0 power is 1. So this is what we're taking the derivative of. So this means f prime of 0. That's what we're trying to find. So f prime of x, the derivative of f to the x is 5 to the x times by the natural log of 5. And f prime of 0 is going to be equal to 5 to the 0 times by the natural log of 5. That's just going to be the natural log of 5 because 5 to the 0 is 1. So natural log of 5. 8. If f of x equals sine of x, then we're trying to figure out what this is right here. Now the tricky part about this one is, yes, we're using the definition of a derivative, of course, but notice here that we're not lined up. This should be first, and this should be last. Sounds like a scripture verse or something like that. Sorry. So to make this first, we're going to have to take out a negative. Now, I'm going to put the negative on the outside of the limit. You can do that. So that's negative limit as x approaches 2 pi of f of x minus f of 2 pi over x minus 2 pi. So this is the function, and we're taking the derivative at 2 pi, but also notice that we're negative. So this is saying the same thing as negative, we'll say d dx of sine of x at x equals 2 pi. That's what we're doing. So negative, what's the derivative of sine? The derivative of sine is cosine of x, and we want to evaluate this at x equals 2 pi. And so that's going to be equal to negative cosine of 2 pi. And 2 pi is 1, so negative 1 is what that's equal to. 9, let f be the function given here. What is the value of f prime of 0? So let's do f prime of x first. Derivative of cosine is negative, so negative 2 sine of x. The derivative of cosine is negative sine, so negative 2 sine of x, plus 3 e to the x, because the derivative of e to the x is e to the x, so that just stays the same. And then f prime of 0, that's going to be negative 2 sine of 0, plus 3 e to the 0. Sine of 0 is 0, so that's going to go away. And e to the 0 is 1, so we're going to be left with 3. Okay, looks like we got a free response question. So, at an excavation site, the amount of dirt that has been removed in cubic meters is modeled by the function f defined above, where g is a differentiable function, so g of x is referring to the table and this part of the piecewise function. Where g of t at select values of t are given in the table above. According to the model of f, what is the average rate of change of the amount of dirt removed over the time interval from 6 to 12? So for A, we want the average rate of change from 12 to 6. So we want f of 12 minus f of 6 over 12 minus 6. So f of 12, so I'm going to plug in 12 right here. So f of 12 is equal to g of 12, and g of 12 is 474. Minus f of 6. F of 6 is going to be equal to g of 6, and that's equal to 306. Over 12 minus 6. So you can do the math right there, and you can get the average rate of change. The units for this is going to be, well, okay, let me just go through this. This is going to be 168 over 6, and that's going to be equal to 28, and then the units here, because we're doing a rate of change, it's cubic meters per hour. So meters cubed per hour. There you go. B, use the data in the table to approximate f prime of 9. So f prime of 9 is going to be approximately, so 9 would be in between 10 and 9. So let's best approximate that using the table. So that's 428 minus 376 over 10 minus 8. Go ahead and do the math right there and get your approximation. Units are also going to be meters cubed per hour. For C, is f continuous from 0 to 12? So is this function continuous from 0 to 12? Well, let's look at this instructions right here. At an excavation site, the amount of dirt that has been removed in cubic meters is modeled by the function f defined above, where g is differentiable function. I think we just have to use the definition of continuity. So let's see, the limit as t approaches, so we know here that we're continuous. F is continuous from 0 to 6. We can see that here. We know g is continuous because g is differentiable. So, and so you can see the relationship here. So f of t is going to be equal to g of t from 6 to 12, and g of t is differentiable. Therefore, g of t is continuous. So we're continuous here, we're on the interval, we're continuous on the interval. We just have to make sure that it's continuous. We have to make sure that we're continuous at t equals 6. So the limit as t approaches 6 from the left of f of t is going to be equal to, so that's going to be from the left of 6 is going to be on this side. So if I plug in 6, I'm going to get 306. So it's going to be equal to, let's say this, it's equal to g of 6, which is equal to 306. Now let's try the limit as t approaches 6. Oh my gosh, that was from the right side. I evaluated that from the right side first. Okay, from the left side. From the left side, we're using this function right here. So let's plug in 6 here and see what we get. So that's going to be 48 times by 6 plus 6 squared, and then minus 6 to the third over 12. So use a calculator. Okay, go through these operations here. And if we do that, so 48 times by 6 plus 36 minus 216 over 12, that equals 306. Okay, and I'm not going to forget to state that f of 6 is equal to g of 6 is equal to 306. So, and g of t is differentiable and therefore continuous. And therefore, f of t is continuous on 0 to 12. We prove that we're continuous at. We know that g of t is differentiable. So that means we're continuous on this interval right here, and you should probably state that. We're differentiable, therefore we're continuous. Okay, so that should cover C. For D, find f prime of 2, the instantaneous rate of change of dirt removed. So f prime of 2, that's just going to be the derivative of that part right there. So if I take the derivative, so I'll say f prime of t is going to be equal to 48 plus 2t plus, no, minus, well, okay, so if I drop the 3 down, that's going to be 3/12, so it's going to be 1/4, so that's going to be t squared over 4. Okay, and then I want f prime of 2, so that's going to be 48 plus 4 minus 1, right? So that's going to be equal to 51 meters cubed per hour. There you go. That's f prime of 2. Okay, and that's everything for this homework assignment.